Hello, sir. I am Jeevan Reddy. I am studying second BTech first semester. In the CA2 assignment, I got the topic of self bias and the subject electronic devices and circuits. Subject code is 23ECE 302. My roll number is 234 G1 A0454. My topic is self bias in JFET. JFET means a junction field effect transistor. Junction field effect transistor is a type of field effect transistor that uses a reverse bias junction to control current flow. It has three terminals. One is gate, another one is source, and finally drain, and operates mainly in saturation region. FET are known for their high input impedance and low noise characteristic, making them suitable for various applications. We can observe the picture junction field effect transistor JFET gate gate is and source drain. It is a N channel JFET because the channel is present in N. The P substrates are left and right sides, ohmic contacts, gate G, depletion region, ohmic contacts. Understanding here we discuss about understanding biasing. Biasing in transistor circuit establishes the operating point of the device for optimal performance. It ensures that the transistor operates in the desired region of the output characteristic curve. Proper biasing helps in maintaining the stability and linearity of the JFET's operation. What is self biasing? First, we look about the self biasing. What is self biasing? What is the technique? How it will be implemented? The self bias is a technique that uses the transistor's own characteristic to set its operating point without requiring external biasing components. It will allow for simpler circuit designs and less dependency on external power supply variations. This method is particularly useful in enhancing the thermal stability of the device. Here we can observe the self-bias configuration of JFET mathematical approach. One n-channel JFET is present here. The two capacitors C1, C2 are coupled capacitor are present, and the here in self biasing with compared to other biasing techniques, we will get a RS. RS is an extra, and VDD is a voltage source, and VA is a voltage. Here we will RG also present the drain resistance and gate resistance and the drain current, drain resistance. Cell bias circuit configuration. How the cell bias circuit configuration? A typical cell bias circuit for JFET incorporates a resistor connected to the gate terminal. Here we can look. The resistor was connected to the gate terminal. Voltage drop across the resistor creates a negative gate source voltage, controlling the JFET conductions. This configuration helps us to automatically adjust the gate voltage as the gate current changes. Here we can signal and VDD plus VDD and RD, ID, VDS, RS. Here finally in the last we will go under the circuit. Self-weight configuration mathematical approach, we can derive some values VGS comma I0 ID equal to IS. Here we will take minus IVGS and minus VRS. Then we will develop a equation VRS equal to IS into RS, VGS equal to minus VGS, VGS Q equal to minus IDRS. Here finally we can take the formula of ID equal to IDSS 1 minus VGS by VP whole square. ID equal to IDSS 1 minus VGS by VP whole square. ID equal to, here see here ID equal to 1 DSS 1 plus 1 IDRS V by VP whole square. The ID equal to IDSS by VP square, VP plus I square. Here the formula ABW whole square formula we are using A square plus B square plus 2AB. ID equals to IDSS by VP square plus ID square RS square plus 2 VP IDRS IDSS plus IDSS R square. What are the advantages of self biasing? One significant advantage is reduced complexity circuit design, allowing for smaller PCB layouts. Self biasing provides thermal stability as it mitigates the effects of temperature variations on the operating point. It enhances the reliability of the circuit by minimizing component count and potential points to failure. What are the disadvantages of the self biasing? One drawback is limited control over the JFET of operating point compared to fixed bias circuits. The self bias method may not be suitable for all applications especially those require precise basing. There is no precise basing in the self-biasing technique. Variability in JFET parameters can lead to inconsistent performance in different devices. Here we can observe the picture. The first we are removing the capacitors, and next there is a equivalent circuit. We call it the equivalent circuit. The voltage divider bias JFET. Design consideration. How will you plot a graph of this JFET self biasing circuit? Selecting the appropriate resistor value is crucial for achieving the desired operating point. The temperature coefficient of the resistor must be considered to ensure stability across temperature changes. Circuit layout and component placement can significantly impact the self biasing. What are the applications of JFET? Self biasing is commonly used in amplifiers where high input impedance is there. See here we look over the amplifier. Amplifier will increase the signal strength. It's also utilized in analog signal processing circuits such as oscillators and mixers. The self bias technique can be advantageous in RF applications due to its simplicity and reliability. Comparison with other biasing methods. Self biasing offers greater simplicity compared to fixed bias methods which require additional components. While self biasing provides thermal stability, it may lack the precision of voltage divider bias. Each biasing method has its own benefits and trade offs, making the choice context dependent. Here we'll look at the fixed bias circuit. What is the basic difference between fixed bias circuit and the self bias circuit? Here the RB is present, in self bias circuit the RS is present. Conclusion. Here by this we are successfully completed the self bias technique. Self bias in JFET provided practical approach to establishing a operating points with the minimal components. Understanding the advantages and limitations of self biasing can help in selecting the appropriate basing technique for specific application. As technology advances, self biasing will continue to play a vital role in the design of efficient electronic circuits. Thank you for giving this opportunity, sir.